right, so we've got this bar here. I'm going to draw it over here. Oh, no, I'm not. Here's the bar. And let's draw in the forces. First, we have the force on the end from this sign that says Paul's Auto Repair. Let's call that M number 1G. Then we have this force here from the tension. Draw it like that. We have the weight of the bar itself, which needs to go right in the middle of the bar here. I'll call that M number 2G. And then we have both a horizontal and a vertical force being exerted on the bar by the wall. So I'm going to draw them like this. I'm going to call the horizontal force like that. And then the vertical force, gosh, does it go up or down? I'm thinking up, so I'm going to draw it upward, vertical. Now, those are all of my forces, and I need to answer their questions. And the first question has to do with the tension. So I've got 1, 2, 3, 4, 5 forces here, and I'm going to have to do either force balancing or torque balancing to figure out the tension. Let's start with force balancing and see what that gets us. We've got, in the upward and downward direction, we have the vertical force going up, M2G going down, M1G going down, and a component of the tension pulling up. So that would be plus T sine of 35. That's the angle there, see it? That's for in the y direction. In the x direction, we could have written this force equation. We have the horizontal force pointing to the right, that one, and then the x component of the tension, which would be minus, because it's to the left, t cosine 35. And that has to, both of those have to be equal to 0. Now, I don't want to use either one of these equations to find the tension because I don't know the horizontal or the vertical components of the hinge force here. So that's not going to help me. But it's really pointed out to me that I don't want to have anything to do with these two forces while I'm trying to find the tension. So I'm going to do torque balancing, and I'm going to put my center of rotation here so that I don't have to deal with these forces in the torque equation, because now their lever arm is 0 and ha ha ha, you don't get any torque. So I'm going to start here and go with the 3 forces left that do have torques with this center of rotation and draw their lever arms. So the first lever arm is like this. It goes with M number 2, so I'm going to call it lever arm number 2. It's going to be equal to half the length of the bar, half of 1.7 meters. Then the next one would go over here to the tension, and this one, maybe let's call this just regular R. This lever arm is equal to 1.35 meters. See that from this diagram, 1.35 meters. And then my last lever arm, I'm going to call this lever arm number 1, and that's going to be equal to the whole 1.7 meters. Good. Now we go to angles. The angle here between R2 and M2 is 90, so that's easy. The angle between R and T, this angle right here, that's 35. So that's not so bad. And then this angle here is also 90. So now that I've got my red forces, my green lever arms, my blue lever arms and my green angles, I'm ready to write a torque equation. So my total torque is going to be equal to 0 because nothing's moving. So the first one I'll write, let's think about signs. We have 3 torques. These 2 are pulling downward, making the bar tend to rotate clockwise. And then the tension torque is kind of upward, tending to make the bar rotate counterclockwise. So I can see that these 2 are going to be the same sign, and the tension torque is going to be the opposite sign. So I'm going to do R2 M2G times the sine of 90, which is 1, plus R1 M1G times the sine of 90, which is 1, minus RT sine 35. And this has to add up to 0. So, since I know what R1, R2, and R are, since I know M1 and actually, they didn't tell us the two masses, did they? What they told us was what M2G was in newtons and what M1G was in newtons. So when you go to plug these in, plug in the newtons for that whole thing, right? Then the 3 R's, you plug those in and you'll be able to calculate the tension.